Hello, everybody. So good morning, good afternoon, or good evening, depending on where you are joining us from around the globe. It is my pleasure today to welcome you all to this webinar, which is dedicated to one of the most vital and also rapidly evolving sectors in space, which is the Earth observation. This event is proudly hosted by the IAF Earth Observation Committee and together with the IAF Workforce Development and Young Professionals Program Committee as part of a new initiative, which is the IAF Technical Committee's webinar series. My name is Eleonora Lombardi, and I'm Head of Department at the Amaldi Foundation and Vice Chair of Technical Activities for the IAF Workforce Development and Young Professional Program Committee. And it is my privilege today to guide you through today's sessions, which was not possible without the joint effort of Claudio Miai and also Stefano Pascali, as well as all the committee members hosting it. And of course, it is my pleasure to introduce you an exceptional panel of speakers today. As I was saying, the main topic today will be Earth observation, which is currently playing a fundamental role, not only in advancing scientific knowledge, but also in tackling some of the most pressing challenges of our time, from climate monitoring to disaster management, from agricultural optimization to urban planning. And so today's discussion wants to bring together experts that represent industry, academia, emerging space businesses, which will guide us through this conversation, highlighting the diverse perspectives shaping the future of Earth observation. So without any further ado, I will introduce you our speakers. So today we have with us Luis Ferreira, which is Head of Program Procurement, EO Science and Exploration at Airbus, bringing key insights from one of the industry leaders in Earth observation systems. We have Anna Maria Nassisi, Manager for Space Economy, Observation and Navigation at Thales Alenia Space, offering expertise at the intersection of technology and the broader space economy. Shmrit Maman, Senior Scientist at the Ben Gurion University of the Negev, contributing a research-driven view on how Earth observation supports sustainable development. Alexandra Gercaiano, Senior Business Development Manager at NARA Space, that will share perspective from an agile, innovative EO company pushing boundaries in the new space sector. And last but not least, Camilo Reyes, Mechanical and Satellite Engineer and Space Development Strategist at the Infinity Air Group, who will provide a dynamic viewpoint that blends engineering and strategic vision, especially relevant for emerging space nations and applications. So together today, they will help us explore how Earth observation is evolving, not only on the technological side, but also in its accessibility, its integration into policy and economy, and its role in the workforce development. So thank you all for joining us. Again, without any further ado, I will start with a very first question to Luis Ferreira, which is also chair of the committee who is hosting us today. So Luis, as chair of the committee, how do you see the future roadmap of Earth observation evolving within the IAF to maximize societal impact and environmental stewardship?
Thanks, Eleonora. Thanks, everyone. Very good day, everyone that is watching. Thanks for the opportunity and invitation for this webinar series. And it's an honor for me, our chair team, and our members in the committee to take part in this. So thanks so much. We, at the committee, we bring together experts, professionals in the Earth observation domain across the world. So it's a very good platform to stimulate these sort of discussions. So going to the question, in a simple terms, I would summarize that Earth observation, the domain itself, it will only continue to grow. I could not conceive a scenario under which the importance of Earth observation will be maintained or would be reduced. Maybe it's my limitation, but I cannot think of it. the importance for citizens, the importance for the public institutions, for businesses, also for countries in terms of sovereign aspects. I cannot conceive a scenario under which it will not continue to grow overall. All of it supported by the fundamental science, earth science, which is the basics, also in terms of technology and the science of engineering to build the sensors and all the things that we need, and also the infrastructure that we need in order to transform data into something meaningful to all of us, and also in terms of data science. Of course, across many axes, policy, intergovernmental, technology, integration, applications, and also tangible use cases across sea, land, atmosphere, you name it. I would like to bring here to the discussion as an introduction as well a few trends that I would like to highlight, a few ones, and also pave the way for the discussion. So I will bring 4 trends that I think are going to be very relevant in the next few years. The first one, it's the trend that we see more and more fusion, more and more data sources, and therefore we will need to see more fusion of those data, and we will see a stepwise integration. So there's already quite some effort into doing that, but this will continue and it will intensify, not only in terms of the quantity and the quality of the sensors, but also the type of sensors, beyond the traditional optical imaging radar, more and more hyperspectral, more and more RF, also other bands, optical bands in the thermal infrared, shortwave infrared, and so on. I think this is one of the trends that we'll see more and more, really the fusion of all these data sources. What we will go into, it's what we talk about, the digital twin of the Earth, which is something that it's already existing, but it will only continue being more tuned and more accessible for everyone. And this brings me to the second point that I wanted to say. The second trend is in terms of better predictability. Of course, Earth observation is the pillar of our awareness of the environment around us in our planet. So there are two important things: the predictability of what is going to happen next, being it disaster or not, simply understanding what is happening right now and predicting a little bit the future, maybe the next day, maybe the next hour. This will continue being improved. And the second one that I want to say in this is accessibility. I believe we still don't have yet, let's say, the access immediate all across the world in terms of what is happening around us and having information coming to us timely. So this will only be intensified. I think an important trend here in Earth observation is really the integration of Earth observation systems also with telecom, satellite constellations that will ensure that we have in real time information of what is happening around us. Of course, in space data processing, all that will allow us to have more timely information about our planet and about our surroundings. The third trend that I will also highlight is the need to have trusted sources of data. When we talk about Earth observation, it's all about data, but do we really trust the source? Do we really trust the sensors under which that data is originating from? Do we trust the data transmission chain so that we keep trusting the outcome of it? Do we trust the processing and all that? And I think there is a lot that we will be seeing in this, and it's super important for our societies and our people, each citizen, that they trust the data that we are going to get out of Earth observation. The fourth one I would highlight, we will talk more about during the next minutes, is also this continuing trend of the private Earth observation enterprise. I do believe that it will continue, it will further develop. There will be space for that, but of course also anchored into governmental needs, public needs, because also there's so much one can do in terms of pushing technology and the boundaries if there is no also support in terms of basic research and basic capabilities, so that then private enterprise can take further. So I would summarize for now these 4 trends. I think some of it we will discuss later on. I just want to conclude also that the future is exciting. As I said, I cannot conceive a scenario where Earth observation will be less relevant than what it is today, certainly more. And our committee and the IAF, we will continue with the mission to elevate these topics at our committee and bring those to the IAF, to the IAC, to the relevant conferences, so that we can maintain the level of conversation adequate and to the level of the importance that Earth observation is.
All right, thank you very much, Luis, for this really deep dive into EO EO sector in very straightforward in 4 main points. So you already mentioned some key points, going from technology to data, to the relation between public and private sectors. So I would go on addressing Anna Maria, who is also vice chair of the committee, and of course someone who is deeply involved in the space economy. So my question to you is, how do you envision EO data shaping public-private investment strategies for sustainable development across Europe, but more in general for the development of the sector on your industrial point of view?
Thank you very much, Eleonora. And first of all, I apologize for my low voice, but the period is very strange with our climate changes. Anyway, thanks for the question, because the answer is a very challenge. You have to take into account that in Europe we speak about the public-private partnership model at the beginning of the Galileo system. But it was not so easy to implement, and special for what concerns the Earth observation, because you have to consider that the market of the Earth observation in the years was mainly institutional. This means that in order to justify an investment from the private sector, it's important to have revenue, because if we don't have revenue, the model, any business case is not sustainable. So this means that the PPP model is strictly related to the business case that we want to implement. And this means that you have to consider that the involvement of the public sector invest in the sector, because have a return in terms of benefit for the community, by consider a lot of application that we can provide for the public sector. Excuse me.
Yeah, no problem.
I apologize.
Take your time.
It's very difficult for me today. Like the disaster management or other application, which management is in the hand of the public sector. There are anyway other application like agriculture or other utility and so on, that could be provide a profit. So take into account that the satellite go around the Earth, and every time you will occur around the globe, the use of the data could be different. And is it possible to merge the two needs? And to have the involvement of the private public sector is important also for the industry in order to improve the data, the information, more than the data, the information needed. Because today the status is totally changed. If we consider the amount of data that we have today is not comparable with the past. And this is the reason why, as mentioned by Luis, the digital twin that will include anyway the artificial intelligence algorithm is possible today thanks to the high amount of the data and high powering of a computer. So I think that today is a matter the status to go through a PPP model, but gradually. It's not possible to have a switch on off. This is my opinion. And if we see also outside of Europe, there is a very interesting example also in India. For example, they are trying to have this model at the system level, not only by application. And because they consider important for the country to be independent for data and to provide a more stronger space economy. That means to increment all the worker in the field, and this is important for the growing of the country. So another aspect is relevant also to the sustainability. Because as I said at the beginning, in order to have the possibility to include the private sector, it's important to define business case where we have revenue. Otherwise, it's not sustainable if we have only investment from the public. So this is the global scenario where I think will be the trend in the future. And we have also a long discussion about it also in Italy with the next Iride constellation that today is financed by public money, but the future is the sustainability of the whole constellation with the participation of the private sector.
Fantastic. Thank you very much, Anna Maria. Sorry if I interrupted you. Do you want to?
No, it's okay. I have finished. I apologize only for my voice, and it's difficult to express.
No, but we have heard you very well, and thank you for your point of view. Just to wrap up, we have spoken with Luis on this overview of EO technologies, data. With Anna Maria, we have touched the EO commercialization. I would like to add another piece of the puzzle, addressing the academic side, so Shimrit, and bringing it EO science. So your academic research mainly focus on the role of Earth observation technologies for environmental monitoring. And so in the field of geoscience, what do you think are the next innovations back through that the next generation should focus on to tackle, I mean, all the challenges that our previous speakers have already mentioned, like desertification, water scarcity, and how can we better guide them towards that and support them in driving this breakthrough forward.
Okay, thank you so much. And Anna Maria, I hope you feel better during the talk, but you're really brave. Anyways, thank you for having us, and it's a great pleasure to be here. And I do want to build upon what Luis started off with, okay? Because he did talk about predictive capabilities. And in order to understand the predictive capabilities, we have to understand that in order to predict, we really need to understand the data we have and what we collected already, and what insights and scientific insights we understand now that could help us with these predictions. And that brings us to what Anna Maria said about the AI applications. So the funny thing about the stage we're currently are in, especially for in academia, is that we always have this lag between technology advancements and then scientific breakthroughs. Okay, and it comes together, we have these gaps, and this is how we progress. So I feel we're exactly at that stage where we had a really great breakthrough with the technology, and now scientific insights are gonna leap forward, especially with everything that has to do with applications. And one of the things that I would advise the young generation, even though I still consider myself young, but that's for a different call, is to invest in foundation models for Earth observations. Just like we had the large language models that transformed how we think of text, right? There's like, I don't know a single person today that doesn't use ChatGPT or any other AI model in their everyday life. I think that was a big game changer. So think about these foundation models for Earth observations. And why am I emphasizing that for scientific purposes is because when you think about it, and this is one of the big things we learned after the Glock that was in Oslo, that our committee is also a very big contributor to. And we had Ale that is not with us today, but he was the chair over there. And we're preparing for the next Glock. But one of the main things that came over there was that 90% of satellite data was unprocessed. So we collected all this data, and we have a lot of data that we could process for climate change, but it's basically untouched. So think about those capabilities, just like we said, we had these large language models. Think about that, but for Earth observation purposes. And when you have that amount of data, you basically own the future, because you could go back and train these models, right? And then we could get our predictive models, just like Louise said. Okay, that was a great emphasis, and thank you for setting the ground for my answer. But we could do that now because we could understand and test these models going back. We have 60 years of Earth observation, right? Once we have that, we basically own the future. And the thing is that this is where I expect these academic breakthroughs, because we are closing in on that technological gap. And the way we think about all the data that is collected regarding climate change, and that's another thing that was discussed in the Glock, is that most people aren't aware that 50% of the data collected regarding climate change, and this is true for water scarcity or desertification and everything else, comes from satellite Earth observation. Okay, so that's a great amount of data. That's a great amount of inputs for our analysis. Now, in the past years, we've transformed also in the way we approach that data. Okay, we are using an approach that is called ARD, analysis ready data now, right? It's not like when I was a student back then, when dinosaurs ruled the earth. Okay, we had to process the data on ourselves, and we used to download the image, and every image would be very costly. Basically, the way we treat data now is we have everything in our cell phone, right? Everything is just like very accessible, very reachable, and somebody is processing this data for us. And that enables us to really invest in these foundation models, in these predictive capabilities. And if I would, the current state that I'm taking my research to is to early warning systems, because we know, especially with climate change, and these are all the models that already been validated. And, we just experienced this last week in Texas with those horrific flash floods. Okay. But we know that it's coming. We know the intensity is going to increase. We know the duration of we know it's coming. We're already witnessing it. Just look back at the past year and you'll understand how many flood events, and we're normalizing these events already. Okay, so climate change is here and it's real and it's now and we're experiencing it. So we have to already be working on the early warning systems in order to save as many lives as possible, in order to reduce the economic damage that will be caused from these events, catastrophic events. And that's the direction I would go into now.
Fantastic. Thank you very much for introducing also this side of the conversation. Now moving also geographically to Asia, I would call on stage Alexandra. So representing again the young generation here, and I mean, in your role of Senior Business Development Manager at NaraSpace, how do you see the role of new Agile satellite missions, and where do you see and how do you see them evolving to meet the needs of the Earth observation sector in different, applications, but also specifically on the climate change, which is quite, very close to us and very real.
Thank you, Leonora, for the question. I hope you can hear me well, and greetings from Seoul, South Korea, everyone. Thank you for having me. So indeed, climate change is probably one of the most urgent global challenges that we're having and we're facing as a species. And of course, we all know here around the table that Earth observations plays a key role in how we understand and how we respond to it. I think a strong indicator of this growing momentum and the discussion about climate change is actually one of our sessions in the IAC Earth Observation Symposium, which really focuses on addressing Earth's environmental and climate change challenges. And although this has been a new session that we've just launched a few years ago, we see that currently this session is gathering the largest number of abstracts from around the world. So definitely, it's a growing momentum for the discussion and the role of Earth observation into climate change. Now, going back to the topic of Agile satellite missions, I believe that they're also an essential part of this discussion, because not just in terms of long-term monitoring trends, but also because they enable faster, more responsive monitoring of disasters, especially when it comes to droughts, floods, wildfires. Shimrit mentioned all of these natural disasters that they're coming fast. So we need data faster and higher revisit times. For example, us at NaraSpace, we're deploying 2 constellations for Earth observation. One is Observer, and the other one is Narsha, which is dedicated to methane monitoring. But we're seeing similar efforts happening globally. So both in Europe and in North America, there's many commercial new companies that are building specific sensors that tackle water quality, wildfire, droughts. And I think this emergence or growth in sensors and data is not just driven by technological advancement, but is also driven to policy. And here, all across the world, different policies are shaping the need for new technologies. From the top of my mind, I can think of the European New Green Deal, or the Global Methane Pledge that are shaping the demand for climate-specific sensors. And I'm very excited for the next few years in terms of Earth observation, because also, as Luis mentioned, we're going to see new sensors coming into the market, new data, and that is not here to replace government scientific data, but rather to complement it in terms of revisit time and also faster deployment of satellite. So in one sense, I see the kind of agile Earth observation or new space missions kind of trying to close the gap between the data and the action on climate change.
Fantastic. Thank you very much, Alex, on pointing this further, topic around Earth observation that, we will reshuffle everything and go on with a second round. But before that, I would like to call on stage Camillo, representing again our young space leaders in another geographical area this time. So we move to Latin America. So on your point of view, so based on your professional experience, what do you think are the main challenges and opportunities of the Earth observation sector, specifically in the Global South, and if and how do you think international cooperation can play a role?
Thank you, Leonora, and thank you for inviting me. It's such an honor and a pleasure at the same time to be here with my colleagues from the Earth Observation Committee. So from my position in Latin America, and of course working at the intersection of aerospace engineering, strategic development, and currently working also for the aviation sector, I see that there are three core challenges for Earth observation infrastructure here in the Global South. From the challenge perspective, I just mentioned that fragmented infrastructure and funding plays a role because, many countries lack consistent ground segments, launch opportunities, or if they have those two, sometimes they even lack a sustainable Earth observation programs and of course funding at the same time, Also limited local capacity for data processing, because even though, we have Earth observation data from several satellites that were launched from local agency, and even though that as well, we have that data that is freely available, it often remains under use due to the skill gaps and lack of analytical tools. And I'm very glad to hear that, for example, Chairman was mentioning how AI is now playing a key role in this one, because let's say we can maybe lack the skills and lack sometimes the big infrastructure, but then we have this global cooperation on AI development that, of course, for Earth observation plays a key role, because now we can process huge amounts of data from the satellites. You ladies were mentioning about 60 years of data. So imagine now processing all that data with AI. So AI is definitely a game changer tool on this. And unfortunately, space is also a geopolitical arena. So we cannot avoid to think about the short political cycles in the region here. For example, in Mexico, presidents change every 6 years. In Colombia, it's every 4 years. So those short political cycles affect, let's say, the space budget. Earth observation investments are often vulnerable to government transitions or lack of long-term planning. So that proposes a challenge. Nonetheless, of course, there is always opportunities, regional collaboration. There is this initiative from, for example, the SIACH partnership between Italy and Argentina. And of course, the programs between Argentina, Brazil, Paraguay, Colombia as well, Peru, where countries pool resources to launch either satellites or to share data, right? And again, the AI is playing a key role on the AI democratization, because there are platforms I'm currently working on one that is called Proxima AI, where it's now possible for non-specialists in agriculture, urban planning, disaster response to extract insights from satellite imagery without, like needing a dedicated space team. And then, of course, I cannot avoid mentioning commercial innovation. In my current role at Infinity Air Group, we have been exploring how like the MRO, maintenance, repair, and overhaul from the aviation infrastructure can support space development, how we can extrapolate this perspective from the aviation sector that, like you launch an aircraft, and then once the aircraft lands, if there is something that needs to be replaced or overhauled, we put it into the place. So now let's do the same for rockets. Let's take reusability at the other stage, because when a rocket lands, there are some parts of the rocket that are thrown away. Why not overhaul those parts and then keep the sustainable cycle rolling, and then, of course, I have to emphasize that our committee, the IAF Observation Committee, we're actively working to welcome like new members from the Global South. And, like it's always fruitful to have a more diverse committee that brings a richer perspective and strengthens the global relevance in our collective Earth observation efforts. Just, like to tackle all the challenges that we are currently facing on Earth.
Thank you very much, Camillo, for bringing this, let's say, last points. So moving on our conversation, I would like to focus on both the challenges and opportunities that you all presented and introduced. So starting with the challenges that you mentioned, so data overload and management, data accessibility and standardization, funding of the mission, policy concern, and so on. Going back to the industrial perspective, so back to Luis, given your leadership in EO program procurement, so what do you think are the priorities and strategies of EO missions now, and what and if do you think that the next generation of professionals can play a role, and if yes, what role?
Thanks for the question, Leonora. Earth observation sector is very dynamic, as we see. Therefore, I think we will be in the need of very experienced people with knowledge of the past, but also always in the need of new ideas, new energy, and also the younger generation. I would tend to think they will be more prone to or having the aptitude to leverage new technology, for instance, AI or others. So I think it's very important to inject that. When it comes to procurement and the challenges, I think there are two sides of it that I would like to bring here to the table. When we think about the public procurement or governmental procurement perspective, I think one of the challenges that we will face, or we are facing already, is that with under the scenario of an increased private enterprise, I think the challenge is really how to establish a procurement approach frameworks that works for a variety of types of missions. So being it more scientific ones, maybe more exquisite, bespoke ones, for which we maybe need to have a certain type of procurement approach. And on the other hand, maybe another one establishing a bit more of flexibility, a level of flexibility that would, and also a level of speed in executing, so that private enterprise can remove uncertainties and being able to deliver according to the expectation. So I think these two procurement, let's say, or the changing role of agencies and the fact that there will be different types of procurement, it's very important to have that flexibility, and is a challenge that the younger generation can help solve. From an industrial perspective, maybe my day-to-day work, I think the challenge is really the speed of innovation that we see everywhere in terms of materials, in terms of equipment, anything that we name it. I think keeping up with that pace and being able to be on top and leverage the best that there is across the supply chain in order to build something which is reliable at the end of the day and according to the schedule and the timeline that we have. I think this is super challenging and important. as Camilo also mentioned, we also live in a geopolitical environment that maybe is less certain than it was a few years ago, and therefore we should expect disruption across our supply chains, basically on basic materials, raw materials, rare earths, and a few other things. So I think we need to inject from the beginning, at least on the private enterprise side, already accept that uncertainty exists, and therefore we need to handle it. So all in all, I also want to conclude on this question because it made me think. I'm an engineer myself, right? So I think moving forward in the next years, where we see these public-private partnerships happening more and more, it's important for young professionals to also have notions of contracts, having notions of commercial aspects. Shimrit, you mentioned the notions of foundational models, AI models. I totally agree. I'm also saying that a portion of the young professionals also, they will need to be proficient on these matters, because at the end of the day, if we have more private enterprise, all these agreements and deals will be done with contracts. So it's also super important. I want to highlight here.
Thank you very much, Luis, also for addressing the challenges on a very positive approach. And indeed, you mentioned the key point of, I think, why all of us love working in the space sector, which is this integration of skills and expertise. And indeed, moving on the opportunities that you have mentioned through your speeches. So, I mean, through Earth observation, we can improve climate action, we can reduce disaster risk, and we can integrate space technologies with several other technologies. We can point to commercial and market growth, but again, focusing on the technological side, back to Anna Maria. I mean, we know that Earth observation is not the only component when we speak about services, because we also have satellite navigation, telecommunications technologies. So what do you think are the opportunities of the integration of the different space technologies, but also with different technologies? So how do you see this point?
Again, also in this case, it will depend from the application that we are doing of our satellite. If we mention, as I said from the other colleague, the part relevant to the climate change, for sure, the Earth observation is the main sources. And in the past, we speak a lot about the integration, but only at application level with the services in order to put together the different capability. Today, in the last 10 years, we have also from a technological point of view, the scenario is changing, because we have the possibility to have an integration, major integration of the capability between the Earth observation and the communication, for example, because the communication is very important to provide all the information in the time requested to the users. So this is important for the downlink, but also important for the interlink satellite. But there is also a future that we are thinking about as a possible storage, not on the Earth, but on the space. And to implement with the devoted satellite also the part relevant to the processing and the archive management. So another aspect is, for example, an integration between the Earth observation and the LEO PNT. that for what concerns the navigation and Earth observation. This means that the possibility to have an integrated approach go in parallel to the different needs that and the evolution of the needs. And from in this perspective, I share what Camillo said, is very important in international cooperation, because today we are able, thanks to the research and development, as said by Schmidt, to have an advancement about the knowledge of the different phenomena. For example, as has been mentioned before, the flooding. The flooding is possible to have a modeling by considering the mathematical function. But there are other catastrophic events, like the earthquake, where it is not possible because we don't have a mathematical function. But today we can, because we have accumulated a lot of data, and we have, thanks to the university and the researcher, we have analyzed which are the possible effects that induce the effects, and by using devoted algorithm of artificial intelligence, we can also to have a prediction what could be happen when we have some trigger factor. So this is an aspect that go together with the use of the other application, satellite application, like navigation, because it is important to be precise in the individuation where there is the phenomena evolution. But it's also important with the communication, because it's important to provide data in time by thinking a different solution. But in a lot of cases, it's important to be fast. And coming back also what said by Alexander about, she said that are complementary. This is the keyword. The keyword that it is not to fight big satellite, small satellite, and so on, but the future is a mixing, because all the different classes are important and are complementary, and only to work together at international level and between the different class of satellite, we can really have a benefit managing the environment of our Earth. And other element that is also important, that is mentioned by Camillo, is the fragmentation. Is it true that we have a lot of ground segment distributed around the globe? And perhaps it's a time to think about a new design, a new solution. I mentioned before the possibility to have on space demanded all of the part of it, relevant to the archive, to the processing, and so on. So that I think that we are living a very enthusiastic period, because we have the possibility to have an open mind approach and to think about a new solution. And the young people in this context are very, very important because they have they are the possibility to speed up this process, in my thinking.
Thank you. Thank you very much, Anna Maria. And indeed, I would like to still focus on continuing this conversation on the development and deployment of integrated solutions and applications. Moving to Shimrit, so coming from the again the solutions coming from the integration of Earth observation technologies with other technologies, how do you see the collaboration between academic institutions, industry, and government to boost that?
Well, first of all, we need someone with that mindset, okay? Because if we're not on the same mindset, that's not going to happen. And I'm going to continue. I'm going to build up on Alexandra's and Anna Maria's previous statements. In order for it to be successful, and in order for it to be actionable, and to have that some kind of solution for whatever problem we're dealing with, everybody needs to benefit from the process. So from my own experience, the best way to do so is to have some kind of flagship project, okay? And then everybody could collaborate their part. And for example, I could give you what we did we started this project over 15 years ago, but but it changed a lot of perspectives for us as well. We had our students come in and say, hey, we have a lot of theory regarding space technology, space applications, space everything, but we are lacking the actionable hands-on experience with the industry and with the government, okay? So what we did is we came up with this great project and we said, you know what, let's have fun. Let's send the nano satellite to space. And that's what we did. We had the BGU set, a 3U nano satellite with very actionable items for sustainable development and climate change. Okay, this satellite was designed to monitor CO2 concentrations and study cloud formations, etc., etc. But when you have such a flagship project that takes the government and the industry and the academia, then you have a lot of pillars of knowledge exchange, some kind of human resources that could follow some kind of path and later work. They came from academia, they're moving into the industry, but they could work on something together that is structured by some kind of flagship project. So if you have the right mindset and you're set on the goals, you'll find a way to do it. From our experience, everybody needs to benefit from that progress.
Fantastic. So very last two questions to both Alexandra and Camillo. So for Alexandra's, so how do you see Earth observation data supporting the empowerment of underrepresented regions, but also non-traditional stakeholders, and complementing that, but this is more for Camillo, representing our young professionals. What do you think it is the role of the young professionals to bridge the gap between engineering and policy making in Earth observation? So I leave you the floor.
I'll start first, because it's true that access to data is a very important topic, but also a big challenge all around the world. I think not just in underrepresented regions, because even though access to data is better and it's increasing, and programs like Copernicus and Landsat, which provide free data, have played a major role in facilitating or improving access to data. I think there's still a huge gap that we're suffering from, and that is the gap between awareness and data uptake. Because all although we have all of these data, we're still missing tools, we're still missing users in many regions across the world. For us on our side, just a brief example of what we're doing here in South Korea is that we're cooperating closely with the media here in South Korea, and we publish, for example, weekly articles in the general media trying to educate the public about the benefits of satellite-based applications, whether this is monitoring heat islands in cities or monitoring forestry. We try to provide articles which are very user-friendly to the media every week to try to increase this awareness of what can Earth observation data do. This is just an example of what we're doing here in South Korea, but this can be easily replicated in other regions around the world. And I think both industry as well as government and NGOs, all of us have this educator, let's say, mandate and being an ambassador in the Earth observation field to try to really increase that awareness and uptake all across the world.
Camillo, back to you.
Yeah. So definitely, I would say that, like interdisciplinary thinking, like I think like we engineers, I'm also an engineer myself, as Luis, we need to have like an understanding not only on how to build satellites or like how they work, but also like why do they matter? Like how satellites support Earth observation and how that the data that they produce support like policies on climate resilience, food security, environmental justice, these kind of things that we usually tend to just like oversee because we're always thinking on how the satellite works, like how the thruster, at what moment we need to fire the thruster to do like an station keeping, like these kind of things. We tend to oversee why the satellite is there. Like I used to work as a spacecraft controller for SES in Luxembourg. And with the controllers, we were always thinking about like, telemetry perspective, like if there is an alarm, how we do mitigation. And I was always keeping in the back of my mind, like we are providing telecommunication services for almost 99% of global population. And that has a big impact. Just think on those little girls in India or Southeast Asia or in remote areas in my own region here in Latin America, how they are using connectivity for education, like for advancing themselves, like when you are an engineer and you lose sight of this, it's like if the things don't matter because you're only having like this technical perspective. So that's why having like this interdisciplinary thinking is very important. And I must mention, now thinking that Alexandra was mentioning like the initiatives in South Korea, the International Space University is currently having the space studies program in South Korea. Like if there are any young professionals out there like watching us at the moment, I would encourage you to join programs like ISU, the Space Generation Advisory Council, and of course like other programs like the IAF Next Generation program or the UN Spider, that provides you with this like global mindset that will allow you to do better and of course to be better in your career, because we are not an AI, we are not robots, we are not rovers. We are part of a global community and we are all members of a spaceship Earth, and how are we taking care of it? So that's the kind of perspective that I like to bring into this session.
Thank you. Thank you very much to both to bringing a very concrete point of view. So if you agree, I will now move very quickly to some questions that we have from the audience. So first question asks that from the committee's perspective, what is the single most significant impediment to unlocking these archives? A lack of standards for AI-ready material, the enormous expense of reprocessing, or the lack of clear economic incentives. So I would readdress that to Shimrit, if you agree.
Yes, of course. Sure. Thank you for that question. That's a great question, but I don't think that's those are the solutions. It's all about doing it. Okay, you have to be very, very proactive. And this is the key for everything this generation needs. If you come with a great initiative and a great solution to a problem, everyone will follow. And this is something you have to understand. It's not that the data is not there or it's too expensive. It's just you have to have that great idea and start working on it. And also, I would add, don't sell that idea to somebody else. Do it and take that that solution to whoever you want to progress it with. But it's out there, just do it.
Perfect, very straightforward. Question number 2, but it's basically a continuation of the previous one. So also, what novel public-private partnership models could transform the systematic reanalysis of these historical archives into a long-term and commercially viable business rather than a one-off academic exercise? So maybe I can address that to Luis.
Yes, I can address it. I'll start. Well, it's a great question, a difficult one. So I don't know, but maybe I can elaborate on that. So I would think that it's always good simply to give access, right? So whoever is there, whoever has access to these archives, to this great amount of data, to give access and so that others can look into it and maybe they can find use cases. I think it would be a pity or a mistake to try to frame in a way already from the beginning without understanding what it could be used for. Would it be used for some specific case? We should not already make those preconceptions. We should simply share and allow other people to take a look and see if there is value out of it. Then, of course, I think there should be already some ideas of frameworks. For instance, how the cost and the risk can be shared between two parties. I think this is very important because if I put myself in the shoes of an entrepreneur, it's about certainty and being able to put a business model together. So these are things from the beginning that any entrepreneur will have those basic questions. And my recommendation would simply do to do a request for information or simply ask potential people interested, like what would they need in order to leverage that data. And from that moment on, the conversation starts. I don't know, Ana Maria, if you want to comment on this one.
No, I share because at the moment I don't see a real business standalone based on all the very long archive, but for sure is important for the future in order to provide the right support to the evolution of information that we can provide to the final user. This is the target. And the private investment, together with the public investment, are important to put together the different needs. And of course, as I said at the beginning, it will depend from the specific application.
So, thank you very much for answering these questions. We do not have any other question here. So we have come to the end of today's webinar, and I would like to thank you, our speakers, for joining us and for sharing their insights, and of course, the overall EO committee. All the team members behind the scenes that made it possible, and of course, all the participants. Stay tuned because other webinars are coming, so follow us on social media and stay tuned on the newsletter. So thank you all and see you soon.
Thank you.
Thanks, everyone.
Bye-bye to all, and I apologize for my voice.
Thank you everyone for joining us.
And we're
Bye-bye.
waiting to see you in our committee.
Yeah, please join us in our committee.